49.
The Radio Wammo Breakfast.
Kiwi.
Oh, now it's Dylan Storey with Dylan Storey's Astronomy, amateur astronomist, enthusiast, and also representative of the Stardome Observatory in Auckland City. Dylan, good morning to you.
Good morning, Wammo. Yes, brought to you by Stardome Observatory.
Yes, and first up we're talking today about NASA, who are planning a flyby of a comet. They're going to buzz a comet. Tell us about this.
They are. It's actually the 5th comet flyby to date. And the main function of this mission is to confirm findings in previous missions, because that's the scientific way. You observe something once, and there could be a number of anomalies which cause it to not be true. But if you can repeat that information, then you're on the way to getting a confirmed theory.
What's the name of this comet?
It's called Epoxy.
Epoxy. I've never heard of it.
Yeah, NASA, they love their acronyms. And it's actually combined out of 2 missions, one called Epoch and one called Dixie.
Okay.
They cleverly made Epoxy.
Yeah. Right.
It's actually a leftover spacecraft from a previous mission, which was also sent to look at a comet. They still had some fuel left and the equipment was working, so they decided to send it off on another mission. And it used an Earth gravity assist as it went past Earth. Got to understand that the rocket motors actually won't get you far in space when you're in orbit around the sun.
Mm.
The actual rocket propulsion doesn't do much. It can only alter trajectories slightly as regards to the orbit it's already in. So when it's passing Earth, just the little rocket firing at the right time can then use Earth's gravity to sort of sling it in a certain direction. So they sent it after this comet, and they needed to get funding for the mission. It was an extra 2 years to get from this Earth pass-by out to the Comet Hartley, it's called, and it's about to get there. It's going to be there in a few days, November the 4th, I think.
And so is it going to go through the tail of the comet, is it?
I don't think so. This one, it's not a sample collect mission. That the tail can potentially cloud the instrument. So it's more just going to fly by and take some close-up photos of what's going on inside a comet to try and figure out what sort of chemicals, what sort of building blocks the comet's made of.
Okay.
Comets are really interesting to study because they're basically bits of rock. Of rock and ice, bits of stuff which are left over from the formation of the solar system. Yeah. So if we can get an idea of what's inside a comet, we can get an idea of what the conditions on Earth were like about 5 billion years ago, and how things were formed, and it contributes greatly to this grand theory of everything that scientists really like.
So essentially, it's gonna fly pretty close, take some photos. Analyze what it can, and then what? It's pretty much over for that spacecraft.
Yeah, basically. Oh. Unless I don't know how much fuel it's got left. Unless they decide its trajectory then lines up that it could meet up with another body in another 3 years or something. It's
a little bit sad for that spacecraft. Always feel, I don't know, just a little bit of sadness.
It'll be out there, just out in the middle of nowhere, floating around. So hey, eternity. It's quite a funny one because it's something to do with the way the instruments work now. It can't study the comet and broadcast back to Earth, so it has to look at the comet for, I think it's about 5 hours, and then turn around and then beam all the information back to Earth, and then so it's constantly looking and looking back.
Oh right, okay. So it's got to beam the information in the right direction, obviously.
Yeah. Another thing that's quite useful for is that when it turns around to beam back at Earth, it looks at Earth in the way that we look at extrasolar planets. So it's looking for those telltale signatures of Earth from afar that we might like to look for when we're looking at planets around other stars. So it's got a lot of purposes.
Very cool. Over the past few weeks, you've been hassling me to get the telescope out and actually stare at the night sky, and I did manage to do that on the weekend because it was a lovely weekend, of course, over Labour weekend. Managed to stay in a batch up north. So I thought, I'll drag the telescope along. And so got it out of the city and had a good gander at the moon because it was a full moon on the Saturday night. I was amazed. Got the damn thing to work straight away.
I'm amazed at that. They usually take ages to set up.
Yeah. And got a good close up of the craters and the little lines and crevices of the moon.
It's got seeing the moon, and actually you can see that there's all these massive features there, these big mountains and huge things. You can see all this detail. One of my favourite times to look at the moon is not full moon, but on a half moon.
Okay.
So you've got basically a half circle. You've got the terminator line there. You've got the sun shining off from a right angle from 90 degrees. So on what we call the terminator between light and dark, there's a certain phase of the moon where you can see some lighted things appearing to hang there in space in the dark part, near the light part. So what they are is the peaks of mountains.
Of course.
Sticking up that are getting the sun, but the bottom of them is not. So you can get a real idea of the topography of the moon at that particular moon phase.
Oh, cool. All right. Well, I'll remember that for next time. I did find it a little bit frustrating trying to look at other stars, or even I think I was trying to look at Venus, and it just still looked pretty much like a white dot. I really couldn't get anything more out of it.
Yeah. How big is your telescope? 6-inch, eh?
I think so.
Yeah. You need a reasonable telescope to see Venus in decent viewing conditions, but in the right viewing conditions, and when Venus is in the right phase, which it's not now, you can see the arc. You can see that it's not a full circle. It's like a crescent moon. So that's quite cool. You know, that was one of the things that Galileo saw that led him to realise that it's going around the sun and not vice versa.
Yeah.
But Venus has basically disappeared now for anyone who's been watching the night sky. It was up in the sky for several months, since about June, I think. And all of a sudden, over the space of about a week, it suddenly got lower and lower and disappeared. So it's overtaking us. So you wouldn't have seen much of Venus because the light that's coming from it would have just been coming from a very thin little crescent underneath it. But when Venus is at half phase, that's when it's really good to view.
Oh, well, that was my problem. Hey, what's happening at the Stardome this week?
There is an open day on Sunday, which means you can go in and look at all the new foyer exhibits and do all that sort of stuff. And there will be planetarium shows running, which are available for a gold coin. I think it's a gold coin donation, or $2 or something extraordinarily cheap. So you can go in and have a sample of that immersive planetarium environment. Cool.
And as you say, the foyer has been redone, and so there's a whole lot of new exhibits in there as well.
Yeah, well, it really looks and feels like a space museum now, and you go in and there's all these things you can do, and fun facts about space, I guess you could say.
Great.
And there's a thing called a magic planet, which is a sphere with a projection on it. It's basically a round, a spherical projection screen, so you can project sort of images of the planets in their real shape and show how things like that move.
Cool. So go check out the Auckland Stardome Observatory. Thanks very much, Dylan. We'll catch you next week.
Thank you, Wammo.
Dylan Storey with some Dylan Storey's astronomy there here.